What if the most powerful creatures on the planet weren't humans? What if they were already all around us, in our homes, in our gardens, in the hospitals where we are, and even in the wars we're fighting today? We're talking about what they call insects. Who is really dominating the earth?
Today, it's insects that dominate the Earth. It's estimated that there are about 10 quintillion insects.
If I understand correctly, we are roommates with insects.
You're absolutely right. We are roommates with insects. They existed before us.
What? Entomology, huh?
Entomology is a scientific discipline that focuses on the study of insects.
Are all small creatures we identify considered insects?
Not all small creatures are insects, because insects have certain characteristics unique to them.
Dr. Exilien Roubaix, an entomologist, is a researcher who has collaborated on several research projects around the world, especially in Europe. Along with the United States, he is one of the people I know who is truly passionate about this subject. Is it true that some artificial intelligence algorithms are inspired by the way insects live together?
Computer scientists themselves call this artificial intelligence. They specifically call it swarm intelligence. It's one of the most copied models in modern times. They copy a lot from ants.
We are going to discover what we call robot insects, which have already made their way into some laboratories around the world, which are a group of artificial intelligence insects capable of organizing themselves. Is this science fiction or not? Does this already exist for you? When we talk about robot insects,
It's reality, not science fiction.
today for me it's a great pleasure to welcome Dr. Exilien Roubaix, an entomologist, a researcher who collaborates on several research projects around the world. I can even say in Europe and in the United States. He is one of the people I know who is truly passionate about the subject we are going to discuss today. Dr. Romain, welcome to Think and Evolve.
Thank you, Jeff, for inviting me to this show. We're going to talk about a really interesting topic. We're going to talk about insects. Well, maybe for a lot of people, as soon as they hear about insects, they already get discouraged. But we're going to talk about it in a way that we can know what an insect is, what they represent in nature, and how humans have used the ways insects develop to benefit people.
Thank you, Dr. Exilien, first of all, what is entomology?
Entomology is a scientific discipline that focuses on the study of insects. It studies the relationship between insects and humans, as well as their relationship with the ecosystem and the environment, and also examines their interactions with other living organisms.
Thank you for the definition and explanation you gave us about the word entomology. And I think that our listeners can now have a better understanding of what it is. So I have another question for you, Doctor. Are all the little creatures we see, can we identify them all as insects?
Not all little creatures are insects because insects have their own specific characteristics, but often people tend to confuse all little creatures as belonging to a single group or even a single species. Generally, insects have a morphology and anatomy that is truly unique to them, just as there are other small creatures that have their own unique morphology and anatomy. Let's take, for example, the morphology of an insect. An insect generally has a body divided into three parts, and one of the characteristics that can help someone distinguish them is this. What sets insects apart from all other small creatures is that insects have 6 legs. That's why generally they are called hexapods. They have 3 pairs of legs. This means they are bilaterally symmetrical living organisms with 3 pairs of legs on each side. And another characteristic that insects have, which distinguishes them from other small creatures, is that they have wings and can fly. So if you see a small creature that can fly, you might say it's an insect because all the other groups of small creatures that are in the same group as insects, which are also arthropods, that's what I wanted to say, because insects are part of a group, they are arthropods. But arthropods are not just insects. There are also centipedes, spiders, crabs, etc. Well, among all the groups of arthropods, only insects have this ability to fly. Apart from that, all the other groups of arthropods, the organisms within them, they themselves cannot fly because they do not have wings.
If I understand, all the little creatures we see flying are insects, but if they don't fly, they're not insects. Is that clear?
You're clear, but not entirely, because not all insects have wings. For example, among insects, there's a group that has wings, the insects that live in societies. For example, take ants. I think everyone here knows ants, but not all ants have wings. It's only one group within the ant society that has wings, and that group is the reproductive group. They're the queens, It's not just ants, there are termites too. Those are the ones you see flying around. They too are the same. Groups of insects that live in societies, or let's say in colonies. That is to say, only the males and the queens have wings. The others, however, don't have wings. But as I mentioned earlier, it's easy to distinguish insects from all the other groups of arthropods because insects have bodies that are truly divided into three parts and have three pairs of legs, whereas the other organisms that are part of the arthropods do not have three pairs of legs. There are some that have four pairs of legs, for example, spiders, which have four pairs of legs. And then you have millipedes, which have a lot of legs, and they don't really resemble insects. But insects, they only have three pairs of legs. And for the more evolved insects, the modern insects, most of them have wings.
Earlier, you mentioned that there are evolved insects. Can you give us more details about these evolved insects? Just a little more detail because you said modern evolved insects. What can you tell us about that?
Normally, in the first group of insects that existed, that's why they're not really called insects anymore. They're more often called hexapods because they also have 6 legs. They are considered primitive insects. They also have others that look similar to insects but are a little bit different because they have a number of organs in their bodies that are not as developed as those of modern insects. Their eyes are formed differently and their bodies are also a bit different. So among them, you mostly find them in forests, etc. All of these, you can find them in their natural environments too, but they are really few compared to the insects we see today, the evolved insects that have wings, etc.
Interesting. Now, I'm going to ask you the question that will shock everyone. When we look at all these insects, all those you just mentioned, the question is, who is really dominating the earth? Is it humans? Is it insects? Who is dominating the earth?
Well, you know, Jeff, for me, here's something I want everyone to understand and know. Today, it's insects that are dominating the earth, not humans. A lot of people think that we have the power to do everything, etc. But it's not us humans who are ruling the earth, who are dominating the earth. It's actually the insects.
So, can you explain that? Can you give us more details?
You might find it exaggerated for me to say that I understand, but that's not all I'm saying. It's really insects that are dominating because if we look at it in terms of numbers, the number of insects that exist today, it's estimated that there are about 10 quintillion insects. Do you know what 10 quintillion means? That means you take 10, then you add 6 groups of 3 zeros after it. That's not a number you can even imagine. It's impossible to count 10 quintillion insects. Just to give you an idea, for every human being on Earth, there are about 1.4 billion insects. You see, there should be about 1.4 billion insects. Yeah, what that number represents is, well, a lot. But that's not the most impressive thing. What's even more impressive is the biomass of insects. If you were to take all the insects on the planet and weigh them together, well, their biomass would represent 10 billion tons of carbon. All of humanity in total is about 600 of a billion tons of carbon. So insects alone surpass us by a factor of 170. And if we only consider ants, just ants, which everyone knows, many scientists estimate that their combined mass exceeds that of all the mammals living on the planet. That includes whales, which are the largest animals on Earth. In the water, there are elephants, humans. If you combine all of them together, the mass of ants weighs more than us.
That sounds exaggerated, but that's really how it is because just imagine that insects are all that and they're the ones actually dominating the earth. If I understand correctly, can we say that we humans are neighbors, we're roommates with insects? Is that it? Can we say that?
Exactly, you're absolutely right. We are roommates with insects. So we humans shouldn't think that we have the power to do everything while the insects are just there and we don't even pay attention to them. We're like tenants of the insects because actually insects existed before us. Insects have been around for more than 400 million years. To compare, we humans, Homo sapiens, have only been here for about 300,000 years. So insects precede us by a factor of about 1,300. That's just to show you that we are actually quite recent. Compared to insects, which have been here for a long time, they witnessed the disappearance of the dinosaurs. They survived 5 major mass extinctions, one of which wiped out 75% of all life forms on Earth, and they endured it. They made it through. They're still here. They exist. That was 66 million years ago. So they survived every time there was a mass extinction on the planet. So it's not by chance, it's not luck. It's simply a fundamental biological superiority. And one of the most important facts that many people don't consider is that when it comes to insects, scientists have already described about 1 million species, whereas for us humans, there is only one species, Homo sapiens, but insects have about 1 million species that have already been described. It is estimated that there are even more than that, possibly up to 10 million insects on the planet, because every day scientists are working in the great forests. In places like the Amazon rainforest, they are discovering new species every day, every single day. Let me give you a few examples. We'll get to them in a moment, just to show you how we, together with insects, are roommates. And as we move forward, you'll see that instead of seeing insects as just anything and crushing them under our feet, etc., we will come to appreciate the work of insects much more, because what we do in science is copy insects in order to improve our own way of life. That's exactly what we scientists are doing.
Speaking of the work of insects, can you give us detailed reasons about how insects contribute? What kind of work insects are doing for humanity? Can you explain to us the roles they play in the ecosystem?
In fact, insects are the workers themselves. Together, they work a lot because they make living systems function as a whole. If we take, for example, pollination, as we know, is the process that allows plants to produce. So all kinds of things like eating, digging, etc., seeds being eaten, it's thanks to pollination that we are able to have food to eat. If we look at pollination alone, about 75% of cultivated plants in the world depend more or less specifically on pollinators. And these pollinators, above all, are insects. And these insects, the pollinators, we know bees, bumblebees, butterflies, and there are certain species of flies that also do pollination. That means these insects alone provide an economic value estimated at $577 billion per year in global agriculture. We're only talking about pollination, but if we take bees, the production of honey shows us how important honey is nowadays in food, in cosmetics, etc. So it's billions of dollars per year that honey production brings into the global economy. So without pollinating insects, you wouldn't have fruit to eat, you wouldn't have vegetables to eat, you wouldn't have coffee, cocoa, etc. So a third of what we eat comes directly or indirectly from them. We depend on insects.
So that means insects do invisible work that sustains many natural systems and allows them to function well, and most people aren't even aware of this.
Exactly. That means we as humans depend on insects. Without insects, we couldn't exist. Like I said before, let's say that insects themselves actually have more abilities. They have biological superiority over us because they have a greater capacity for adaptation. Well, depending on pollination, but there are other contributions insects make. And here are some of the roles they play in the ecosystem. For example, some insects are decomposers. They actually break down organic matter. When it comes to organic matter, we know that in plants, when the leaves fall to the ground, insects participate in the decomposition of these leaves, which is good for. In agriculture, that means when organic matter decomposes, it creates a lighter soil, a soil that is well aerated, which is good for plant roots and for global production. So without insects, the soil would be dead. In addition to that, insects also play a role in the food chain. Without them, birds, reptiles, amphibians, and mammals couldn't survive because they are the food of birds. They are the food of mammals, reptiles, etc. So in short, we can say that insects are part of the fundamental architecture of life on Earth.
That really makes me think. So without insects, there wouldn't be many crops, there wouldn't be much fruit, and there wouldn't even be chocolate, if I understand correctly.
There wouldn't be any of those things because, as we said, 75% of cultivated plants depend on insects, either partially or completely. So there wouldn't be any of those kinds of products. Actually, we are facing a global food crisis related to insects, the problems with bees, diseases, and also issues with their habitats, the use of chemical products, which have harmful effects on bees.
So I know a lot of people who love chocolate will be surprised to hear this, but yes, without bees, you wouldn't be able to enjoy your chocolate.
Let me tell you something. A lot of people don't really understand the importance of these insects. Every time you see a bee or even a bumblebee or a butterfly landing on a flower, that's pollination at work. They're working for you. Many times people don't understand that. After this show, if you didn't realize how important this is, well, I advise you to go take a look and see for yourself. Watch closely every time an insect, a bee, a bumblebee, or even a butterfly lands on a flower. Observe the action it performs. Because of the vibration, when the insect is on the flower, it allows the pollen to detach and fall onto the stigma, and that's how pollination happens. So the plant can then produce normally. Many plants, when they flower, really depend on insects for reproduction.
That's true. When we see an insect, we rarely think of it as a biological machine that hardly does anything. But science shows that some of them have abilities that go beyond our imagination. Is that true?
Yes, that's right. And I'll give you some examples that might really surprise you. Let's start with the dragonfly because everyone here knows the dragonfly. I remember as a child, we used to run after dragonflies trying to catch them. So the dragonfly we see it's a famous predator. So they have an extremely advanced vision system. Okay, if we look at just the dragonfly's eyes, we'll see that its eyes take up its entire head. Its eyes are touching each other. But the damselfly, on the other hand, has a much wider head because its eyes are really separated. But both are famous predators. If we talk about the dragonfly itself, its eyes cover its entire head. It gives them a 360-degree field of vision. You know what 360 degrees means? That means they have an enormous capacity. They can see ultraviolet rays, polarized light, things that humans can't see. That means they can even detect movements that we ourselves can't even perceive. So, you know the dragonfly's success rate when it comes to predation. That is, when it hunts other insects. Its success rate is 97%. 97%, that means a lot. It's not 50%, it's not 70%, but 97%. Let's imagine that the lion, which is the king of animals and the top predator, the lion's success rate is 25%. Out of every 100 animals the lion hunts, it only manages to capture about 25%. If you take the great white shark, it's about 55%, but for the dragonfly, it's 97%. Can you imagine that?
So, I have a question for you because for me, the dragonfly is called demoiselle. Can you clarify this for me? Because in my mind, in Creole, we call the dragonfly demoiselle, but you said belul. So, can you explain the difference between belul and demoiselle? So, if we compare it to the dragonfly, we can say that the dragonfly functions in the same way with a natural gift for hunting and it can fly with extraordinary precision, which is really impressive. What can you say about that?
Well, let me clarify again. The dragonfly is not the same as the damselfly, but let's talk a bit more about the dragonfly.
Okay, thank you, thank you. Okay, the way I saw the dragonfly, I didn't realize there was a difference between the dragonfly and the damselfly. To me, the dragonfly was the damselfly.
Yeah, sure. Both of them are predators. They're really great predators, in my opinion. But let me say this, the dragonfly is definitely a predator. Actually, among the group of insects, you'll find a lot of insects that are predators. But we're not going to get into that because that's not the topic of today's show. Dragonflies, they're natural killers, really, most of the time. So these are animals that, as scientists, we study, okay? For example, the dragonfly itself can calculate the interception trajectory of a moving target with a precision that even the best current military targeting algorithms can barely match. What's interesting about dragonflies is that they have the ability to anticipate the movement of a target within 30 milliseconds. Even before the prey moves, they've already calculated the trajectory to the exact spot where the prey is about to pass so they can catch it. And that's also why their success rate in terms of predation is enormous. So they perform impressive real-time predictive calculations that many mechanical drones still can't achieve at the moment. And one of their abilities as well, their free body movement. They also have 4 wings that they control independently. This is something most insects can't do. It allows them to fly in 8 different directions. They can glide, they can fly backward, and during flight, they can make instant 180-degree turns. So all of that is remarkable. Do you know how many nerves they have in their brains? With all the intelligence they possess, they have about 1 million neurons. And they dedicate 80% of their neurons to vision because they actually have extremely advanced vision and to movement. Whereas we humans, how many neurons do we have? We humans have about 80 billion neurons, but they only have 1 million, about 1 million, barely 2 million neurons. There is an agency within the US military research sector. It's called DARPA, which funds entire programs to copy the targeting systems of autonomous missiles and combat drones. And all of this is inspired by dragonflies so they can do these things in advance.
And the ants themselves. And they move underground, they organize themselves to eat together, they defend their colony, they work together. People always say that ants are hard workers. And when people observe them, they always see that ants are always working, they never really rest. So how do they manage?
Ants, they live in colonies. As you see today, when you talk about ants, you talk about an ant colony. It's another form of intelligence that is truly extraordinary, not on an individual level, because a single ant doesn't really do much, but on a collective level. A single ant by itself is relatively simple because an ant alone just follows the group, the mass of the colony, and only carries out some basic behaviors. but an entire colony itself becomes a superorganism, a truly remarkable intelligence. And I believe there are a lot of documentaries made about ant colonies. There are a lot of them. We take a few examples. You have the leafcutter ants. Those are the ones from South America. Their colonies can reach up to 8 million individuals. That means a lot of individuals. Together, they can build cities underground with very sophisticated ventilation systems. They have rooms with controlled temperatures. They have optimized logistics networks because they know when the ants themselves go outside to look for food and so on, all of that. They really optimize their logistics networks, and the ants themselves are living beings that have been practicing agriculture for 50 million years. That means they cultivate mushrooms in their specialized chambers to feed themselves and protect them from diseases and so on. They feed their fellow ants and so on, all of that. 50 million years of agriculture. That means they were practicing agriculture even before humans existed. Do you know what that means? It's extraordinary.
Interesting. Let's take a moment to reflect on this because we didn't know that ants have been practicing agriculture for so long and that they were doing it before we even existed. That's truly remarkable. And what's even more amazing in all of this is that when you look at ants, they don't have any directors, they don't have any presidents, they don't hold any meetings. And yet, the entire colony knows exactly what to do, when to do it, and their movements are truly coordinated. It's one of the most astonishing things in nature, and maybe that's one of the reasons why scientists continue to study these insects. It's to understand them. That's part of it. What really amazes me is that when people talk about artificial intelligence, they always think of computers or big data centers like data centers, but they never think about ants. Is it true that some algorithms in artificial intelligence, what we call AI that we use today, are directly inspired by the way insects live together?
Yeah, exactly. Just like we were saying earlier, we said that insects on an individual level are not really extraordinary because each of them operates on a single mechanism. But on a group level, they function really well because they don't need a central command. They don't need a director to organize their work. They organize their work themselves. In fact, the group generally follows a simple rule, and it's from this simplicity that an extraordinary kind of complexity emerges among these insects. And in this sense, computer scientists themselves, they call it swarm intelligence. Today, it's one of the most copied models in modern computing. It's as if they use the intelligence of each individual in a decentralized way to do their work as a group, which allows algorithms to work much more efficiently. They copy a lot from ants, and we'll talk later about how in technology they actually copy ants to improve what they call transportation in humans.
So that means when an ant is looking for food, it's not just thinking about its colony, it's also inspiring technological advances in our daily lives.
Yeah. So all of that is really fascinating. Is that nature in all its creativity is truly limitless. We haven't even talked yet about termites, which are themselves a phenomenal order of insects. So termites, for example, build mounds that can reach up to 9 meters high in Africa. In fact, when people mention termites, they think of wood. And that's because termites cause a lot of problems in construction, especially with wood. That's why generally wood used in construction is treated because otherwise termites will eat it. But it's not only termites that attack wood. So as we just said, termites themselves can build nests up to 9 meters high, which proportionally to their size is like if we were building a building about 2 kilometers tall. And what's impressive is that inside these nests, they maintain a specific temperature. It's not a variable temperature, it's their temperature. Even if it's hot outside, they maintain a constant temperature inside. Around 30 degrees, even when it's very hot or even when it's very cold outside, inside the termite nest, the temperature always stays constant. Not with an air conditioning system, not with human engineers working with thermodynamic software, etc. None of that. It's just tunnels, a network of tunnels that the termite itself creates with perfect aerodynamic precision. Some architects, some who study structures in order to design buildings with low energy consumption, because often when you build large buildings, you need an air conditioning system that uses a lot of electricity. And so termites have inspired many engineers to create buildings that use less energy. One of the examples we have in mind right now is the Eastgate building in Zimbabwe, which is one of the best known examples. They built the building in the same way as termites do. It's something extraordinary, a real masterpiece. They simply balanced a ventilation system, copying the termites, so they could create a masterpiece.
Okay, everything you've explained is truly extraordinary. So this means that when people look at infrastructures, when they travel, there are cities they visit. You can always look at that with Ezekiel and say that Ezekiel is inspired by structures, by great signs that we can see, by constructions, things that are never just random expressions. And just as you explained with ants, that means when we look at the GPS we use, when we find the best route to get somewhere, or when a company optimizes its deliveries. Some of these principles, we can say, come from observations scientists have made about ants, right?
Yeah, exactly. There are a lot of people who are completely unaware that insects are not only technological reservoirs, but they are also sources of inspiration for scientists. And in 1992, there was a Belgian researcher named Marco Dorigo who observed a fascinating phenomenon in ant colonies. It's about how ants always manage to find the shortest path to supply their nest with food. So that was one of the questions Marco asked himself. Imagine, ants themselves don't have maps, they don't have GPS like humans do, they don't make any conscious calculations. It's just pheromones, they use examples, and yet they always quickly find the shortest route to supply their colony. So he transformed this into an algorithm, and this algorithm is called ACO, which stands for Ant Colony Optimization. Today, this algorithm is still being used. It's used to optimize delivery routes for UPS, FedEx, to plan satellite trajectories, and to manage traffic in internet networks. And it also allows for the design of complex electronic circuits, etc. It's really incredible when you think about it without GPS, without anything. Ants are able to optimize, they help humans design technologies that can benefit the population itself.
That makes me realize something. Sometimes the greatest innovations don't come from inventing something entirely new. They come from learning from nature, and nature itself has many years of experience ahead of us. Now, here's the part that makes a lot of people feel like they're living in an episode of Black Mirror. When we talk about robot insects, is this science fiction or does it really exist already?
It's reality, not science fiction. Robot insects truly exist. They're much closer than we might think because there are many researchers working on cyborg insects. They're creatures that are halfway between living beings and machines. We can talk about cockroaches controlled electrically, scarab beetles, rhinoceros beetles equipped with microchips. These are insects fitted with miniature sensors that, through a scientific interface, allow them to be manipulated. Yet, the insect itself is still very much alive. With the help of a sensor, or let's say with the help of an electrode placed on the insect, scientists are able to manipulate it. Let's take as an example one of the major programs that was used, this program called HIMEN. HIMEN is an English acronym that stands for Hybrid Insect Microelectromechanical Systems. Its explicit objective was to implant electronic devices into insects during the development of their larvae. In fact, for those who are not familiar with insects, their development does not happen the same way as ours. Actually, it happens in stages. That is to say, the insect lays eggs and the eggs hatch into larvae, which are often very different from the adult. And it is at the larval stage that they implant a kind of electrode in the insect's nervous system, which will later fuse with the insect's own nervous system. When the insect undergoes metamorphosis and becomes an adult, it grows with the technology inside it, and scientists have a major interface that controls all the insect's movements.
That's really amazing. Are you telling me that scientists have already managed to control the movements of insects with technology, almost like they would control a drone?
Exactly, that's the goal. To implant electrodes so that the insect is alive, a living being that's moving, but it's a human hand controlling all the insect's actions. It's through electrical impulses sent via electrodes placed near the insect's servos in its nervous system, which influence the insect's direction, flight, walking, and so on. So whatever you want the insect to do, that's exactly what the insect does. There's a team led by Michel Mahabiz at the University of California, Berkeley, who demonstrated this with a beetle, a scarab, since 2009. What they do is implant electrodes into the insect's antennae, and then these insects can be remotely controlled. Meanwhile, the insect itself continues to eat, to breathe, to function normally, biologically speaking. But it's as if like a zombie, meaning they are the ones controlling all the insect's movements. So basically, this insect becomes a living robot that repairs itself, consumes only a fraction of the energy of a mechanical equivalent, but can go anywhere. Anywhere you want, even places where a conventional drone can't reach. So that's really interesting.
It's really thrilling because, on one hand, this could help with search and rescue operations after earthquakes. For example, if we take the case of the earthquake that happened in Venezuela, I think that a technology like this, controlling the insect, could allow us to send it into the rubble to detect people who are still alive. But on the other hand, it raises a big ethical question. To what extent should we use living creatures as technological tools? Shouldn't science have its limits?
Yes, as I just said, this raises even more questions. But generally, I think when science does its work, it does it to make life much easier. For example, as I just mentioned, these insects, once they have a sensor on them, you can be in a period of crisis, like during an earthquake, for instance. You remember the earthquake that struck Haiti, and currently we're talking about an earthquake that happened just a few hours ago, where you can send these insects into all the small spaces where conventional drones can't go. And the advantage these insects have is that thanks to their tiny cameras, they can enter through very small holes. They also have CO2 detectors inside and ultra-sensitive microphones. So just from a person's breath, they can immediately detect where the person is. The insects can do that. Thermal and sound mapping of the building is done completely so they can find the victims. Now, if they can use their cyborg sensors in this way, I think it could help people during a natural disaster. But you just mentioned something really interesting, which is the ethical aspect of all this. Absolutely. So I think we'll have to come back to that in the ethical debate section, because the ethical debate is something fundamental and really deserves to be addressed thoroughly.
I think these are questions that society will need to answer and not just let technology develop on its own. There are questions that scientists are raising everywhere, Dr. Exilien. Pollinator populations, especially bees, are declining in many regions around the world today. And we know that without pollination, many crops will not produce. That's where the idea that seems to come from science fiction films comes in, where they talk about robot bees. Is it really possible to use bees, or rather to design robot bees, since we see that bee populations are decreasing in certain regions, to create robot bees that will go and carry out pollination, making it easier for crops to continue to be produced, just like the work that bees used to do? Is that really possible?
The problem with the disappearance of pollinators, and particularly bees, is perhaps the most underestimated ecological crisis of our era. Not many people really talk about it. It's mostly among scientists that we know about it, but humanity doesn't really feel it, because the way bees used to buzz around people's ears in the past, people don't really notice that anymore. Let's say since the 1970s, the population of flying insects in Europe has declined by about 75 to 80%. And in certain regions of Germany, in France, in the United Kingdom, there are entire areas that are completely silent. The buzzing, meaning all the activity of these pollinators, has become silent. The term that scientists use for this is insectageddon, like Armageddon. So that's the term that scientists themselves use for this. You might think that term is exaggerated, but it's not, because the population of pollinators themselves has decreased significantly. And there are many causes behind the decline in pollinator populations. For example, if we take among them, there are pesticides. There is a group of pesticides called neonicotinoids, which attack the nervous system of insects and have an even greater negative impact on bees. Well, if we're talking about pesticides, we can set pesticides aside and look at other causes. For example, bees have a parasite called Varroa destructor, which is a mite that also attacks them and contributes to the decline, or rather contributes to the drop in bee populations. The Varroa destructor parasite is decimating entire colonies across several continents. There are other factors like climate change, etc., which actually desynchronize the flowering of plants from the activity of pollinators. Another factor is the destruction of habitats. That is to say, insects themselves have habitats, they have places that are essential for them. So if you destroy their habitats and there are no flowers for the insects, then the pollinators cannot exist. And if we take all these factors together, if several of them happen at the same time to pollinating insects, that's why their numbers are decreasing considerably. And the consequence is direct and measurable. It's about $577 billion of annual agricultural value that is at risk of collapsing, because we saw what pollination represents in the world in economic terms. So robot bees, yes. So it's a path that researchers are seriously exploring. For example, there are researchers who have developed what they call robo-bees. It's a micro robot about 2 to 3 centimeters wide that can fly, swim, well, when I say swim, I mean on water, that can pollinate just like a real bee, thanks to electrostatic charges, just like real bees have. The way they made the wings, they really imitated bee wings to help this robot bee fly properly. So what it has on it is a cap. They put a light sensor on this robot, which has a small artificial intelligence chip on it, allowing the robot to fly in a semi-autonomous way. In Japan, they have also developed a pollinator robot, which has an adhesive gel on it. This allows that every time the robot lands on a flower, the gel, which has an ionic sensor, captures the pollen. And when it lands on another flower, the pollen falls onto that flower and the flower is then pollinated. So this doesn't work perfectly yet, but researchers have managed to make it work under controlled conditions.
That means if one day the number of natural bees drops too low, humanity would be forced, as they are already starting to do, to develop technologies, robot bees, to help with some of the pollination work that bees used to do. Is that correct?
Yes, this is a central issue for the future of agriculture. In my opinion, I think that in the coming days, if things continue like this, we will be forced to develop them. A lot of robots, if the population of pollinators keeps decreasing like this. Imagine if they decrease, there won't be any pollination. So the total global production will decrease. But let's be honest, today, drones themselves are not ready to truly replace bees. Think about a real bee, a normal bee. It can visit 2,000 flowers per day, can fly for up to 8 hours, and can navigate using GPS, travel distances of several kilometers, and adapt. There are thousands of different plant species, all of that without any cost of production. But in nature, they can produce on their own. But a drone, there isn't a single machine right now that can match the performance that bees have. But the technological trajectory is there. And at the same time, there are agricultural surveillance systems inspired by insects that could change things because there are robots that explore two fields in essence and which collect data on humidity, temperature, which can indicate whether these plants are sick, whether there are populations of pests on these plants, and which provide aggregated information that allows ultra-precise information to be made, or you can treat an entire field, but you can choose an area, exactly the infested area, or an area that is sick. You can treat directly, you can treat an area too. For example, if you see a pest in the field, you treat the entire plot because you're afraid the pest will spread throughout the whole plot. But if there is a tool that can detect which areas have the disease, which areas have the infestation, then only in those places you'll be able to treat exactly where the disease is without having to treat the entire field, without having to put the lives of pollinators at risk.
Well, that's another issue. Wouldn't it be better for us to protect the natural bees? Already their numbers are decreasing in certain regions, and it's said that we could spend billions of dollars trying to replace them with artificial intelligence, with bee drones that can do pollination. Wouldn't it be more important for us to protect the natural bees? People say that with artificial intelligence and bee drones we can really detect diseases, but when you think about it, wouldn't it be better to protect the natural bees instead, or invest the money that would be spent developing robot bees into protecting the natural bees? Think about that.
Absolutely, I agree with you. And in my opinion, it's completely absurd because there is no machine that can match the biological complexity of an insect. Even if science tries to imitate insects to build robot machines to do the same thing, there is no machine that can equal that. If we want to build artificial bees, robot bees, what does that mean? Does that mean we've failed to protect the ones that already exist, the natural bees? I think it would be a technological victory, but it would hide an ecological disaster. For me, I think the real priority is to reduce pesticides, to control the use of pesticides, restore the natural habitats of these insects that have been lost. Okay, sometimes it's not the insects themselves, but it's us who destroy their habitats because of agriculture, housing, etc., urbanization. So I think protecting the species that already exist is what's most important. Or you could always have a plan B, you could say, but it can't be a replacement project.
And indeed, because nature has already invented systems that work extraordinarily well, and maybe for me, the best innovation would be to learn from and protect what we already have. I think that would be very interesting. Let's talk about one of the insects that people are most afraid of on Earth. Let's talk about mosquitoes. Because every year, mosquitoes are responsible for transmitting diseases that affect millions and thousands of people around the world. And that's why many people see mosquitoes only as a threat. But can science change the way we see this insect?
So, okay, from a statistical point of view, mosquitoes today are the deadliest animal in human history. Not hurricanes, not snakes, but mosquitoes. Mosquitoes kill nearly 1 million people every year, mainly through various diseases such as malaria, dengue, yellow fever, chikungunya, Zika, etc. All of these are diseases transmitted by mosquitoes. Mosquitoes are vectors. Mosquitoes carry germs and microbes in their saliva, and when they bite you, because they feed on blood, they transmit those germs to you, and then you get sick. For comparison, snakes kill about 500,000 people per year. Snakes kill about 25,000, etc. But mosquitoes kill nearly 1 million people per year, especially in developing countries where there is a lot of unsanitary conditions, etc. These countries often lack the means to control these vectors, so they cause a lot of damage. If we look at Africa and also a lot of other places in the Caribbean where they don't have enough resources to fight against mosquitoes, well, this leads to many cases of disease, many cases of mortality. So mosquitoes, they surpass everyone else in terms of being disease vectors, in terms of mortality. They have no equal. What they are currently trying to do is infect mosquitoes with a bacterium called Wolbachia. Wolbachia is a bacterium that is not dangerous to humans, but it can affect mosquitoes. That means if this bacterium affects the mosquito will no longer be able to transmit viruses, such as the pathogens that cause dengue, Zika, chikungunya, etc. Another thing is what they call genetically modified mosquitoes, which scientists are also working on, developing mosquitoes that cannot transmit these diseases and that are sterile. They mate with other mosquitoes to reduce the rate of fertilization among natural mosquitoes. These methods are still under scientific review and regulation in several countries. They are being tested before they can be used widely in any country.
We also talk about microbes that are spread by mosquitoes. There are some that can reach places where chemicals cannot. Is this just for serious young scientists, or are we still far from this reality?
Microbes are the boldest frontier, and there are scientists currently testing them. They have imagined prototypes that already exist, biological nanorobots that can navigate through human blood. And these nanorobots, when they navigate in human blood, as soon as they are there, they can identify markers, tumors that can cause cancer. And these nanorobots have the ability to release medication directly inside cancerous cells. In 2021, a study showed that trained bees can detect breast cancer in simple urine samples with an accuracy of about 95%. That means if you train the bee, it has the ability to detect breast cancer. You only need a small urine sample and it will do it. Also, bees themselves have a very advanced sense of smell, about 100 times more sensitive than ours. That means the way they pick up scents, they can detect them. It's a chemical signature, a tiny chemical trace from the tumor at a very early stage, something that a scanner can't even detect. But they can, so the future of medicine is microscopic.
This shows us just how important it is that technology doesn't always try to copy nature. More often, it is inspired by it. It's nature itself that inspires technology, and that's what I've come to understand. But now let's move on to a very sensitive topic. When we talk about drones, we already know a lot. They are used in many conflicts and in people's daily lives. Recently, when we look at the war happening in Ukraine with Russia, the conflict between the United States and Iran, Israel, we clearly see that they use drones a lot. But my question is, can a country develop a system inspired by the way insects work together and then develop weapons to attack other countries? For example, recently I saw that China developed a surveillance drone modeled after a mosquito. Do you think they have reached the point where they can use insects to attack other countries in war? Does this exist today? Are they working on this? What can you tell us about this?
Okay, let's start by documenting what is already public. For example, in 2016, the Pentagon tested an S-203 microdrone. They are called Perdix. They are released from a jet. And these drones, they don't have a single controller. They form autonomous formations. They share information in real time and collectively adapt their behavior. That means they imitate exactly the behavior of insects, the behavior of bees, ants, etc. Each individual drone on its own isn't very useful, but when you take a group of drones together, they can do extraordinary work, just like they imitate the behavior of insects to achieve this. No one directs them, but there is a collective intelligence that functions just like an insect colony. And China is doing the same thing. China made a swarm of 1,180 drones, all in coordinated formation. And then in 2022, it created thousands of units to show you that insects are at the heart of the development of military technology as well. So Jeff, the war of the future could very well look like a colony of artificial insects, because this is a reality that has already begun, because a swarm possesses unique strategic tactical advantages that armies simply cannot ignore. So it's difficult to stop a swarm. You might be able to destroy 10% of a swarm, but you can't destroy them all. Even if some go down, the rest keep working. They'll adapt and adjust. It's exactly the same system as insects. That is to say, if you destroy 10% of an insect swarm, the rest will adapt. If one group in the swarm is neutralized, the other groups will reorganize themselves. That means each group is autonomous. They don't need a human operator, a person to control them, etc. For each unit, they don't need that. There is a collective intelligence just like insect swarms. These groups can make better decisions than an individual, even if you were to listen to or control them yourself. So all of this is directly inspired by bees, ants, termites, etc. And these programs we were talking about called DARPA, and here it connects with our program called Hive Mind. So we were discussing, because insects themselves have microsensors, microphones, cameras, which they use as surveillance vectors. These insects can be used as spies. They can spy on secret meetings, etc. They can go into bunkers. They can search places where people can't enter. So it's truly colossal work that insects have inspired humans to do.
Throughout this whole conversation, there is something that really strikes me. The more I learn about insects, the more I realize they're not just a part of nature. They are one of our sources of inspiration in several fields such as medicine and agriculture, for artificial intelligence, for robotics, and even for the future of technology. But with all these possibilities, there also comes a great responsibility. So the question is not just what we can do, but rather what we should do, because the decisions we make today will define the relationship between humans and technology tomorrow. The last question I have for Dr. Exilien: when you look 50 or 60 years into the future, how do you imagine the relationship between humanity and insects?
That's a very good question you asked, Jeff. Okay, I think we're going to understand something truly essential. Is that insects are not just insignificant creatures that you can crush without thinking. You can step on them. As soon as you see them, you tend to call them pests, say they're harmful insects. But I think, as I've said before, among all the insects that exist on the planet, only a fraction are actually harmful. It's about 1% of the insect population that are pests. So what about all the others? They're not pests, they're just normal insects that are beneficial, often playing an important role in the ecosystem. So insects like the ones we've been talking about are not insignificant creatures. They are the visible architects of the ecosystem. They contribute to the formation of the ecosystem, and we find them as pollinators, decomposers, predators, and so on. And they even provide us with products to eat, like honey, etc. So they are also biological models for the future. And perhaps they are technological inspirations that could one day save us or transform humanity. But for this to happen properly, this conversation and this matter need to move from the laboratory to the general public, because we talk about a lot of things here, but these are not things that people know about. People need to start understanding, well, what science is doing with insects so they can know where these things might lead humanity. There needs to be a debate, and citizens must understand what is being developed in the laboratories. Because the decisions that will shape these technologies over the next 20, 30, or 50 years will be made by a few people with or without public debate. They will make them whether you like it or not. The debates that are held about them, and as for the insects themselves, they have already made their decisions. Because they've been here for a long time, they're not going anywhere. We can't destroy insects. That's something we need to keep in mind. A good example is cockroaches, for instance. They can tolerate doses of radiation 10 times more lethal than humans. If you put a human and a cockroach together somewhere with just a little bit of radiation, the human will die quickly, while the cockroach will keep living normally. And ants, as I mentioned earlier, they have survived 5 major mass extinctions. So if humanity disappears tomorrow, within a century, the ecosystem will rebuild itself around insects. In a very real sense, we are living in the world of insects. We are just temporarily borrowing this world from them to live in, but they will always be here. So that's why we need to understand that insects themselves play a truly important role. And the debate about using insects as a technological reservoir is something that we, the population, need to be aware of. We need to be part of this discussion as a matter of course.
Thank you, Dr. Exilien. Today we took an extraordinary journey. We started with a simple question: who really dominates the planet? And we came to discover a world where insects not only keep our ecosystem alive, they also inspire all the technology we use today. They help science advance, and they can help in the fight against diseases. And perhaps they will play an even more important role in the future of humanity. And I want to thank Dr. Exilien for his analysis and for the explanations he provided that helped us understand the world of insects, the role insects play, and for his passion and ability to make this subject not a complicated one, but truly easy for everyone to understand. And if this episode made you see the world differently, don't forget to share it with your family or friends, because science shouldn't stay only in the laboratory, it should reach everyone. So next time you see an ant on the ground, a bee in a garden, or a dragonfly or butterfly flying along the riverbank, don't look at them as if they're insignificant. See them as one of the greatest gifts of nature, nature that keeps on giving. Because sometimes the greatest sounds come from the tiniest creatures that exist. I am Mr. Jeff Valbrun. Subscribe to the Tech and Evil channel so you don't miss any episode. Thank you for being with me in this and in every episode. See you next time.